In this video, we're going to look at what the graph of the tangent of x is. In trigonometry, the tangent of x, written tan of x, is equal to the sine of x divided by the cosine of x. And the tangent function has a really pretty geometric meaning, which I'm going to get to at the end of the video. But for now, let's just think about what this would look like if we graphed it. So let's get ourselves a nice big graph here. And this will be our x-axis. This will be our y-axis. And let's mark some points. So let's say here, here, here. And what should our increment be? I think it would be good to have an increment of pi over 4. Pi over 4 is kind of the basic unit for the tangent function. So we have pi over 4, pi over 2, 3 pi over 4, pi, and then this would go on and on. We have 5 pi over 4, and then 3 pi halves, and then 7 pi over 4, and then here we're going to get back to 2 pi here, which is going to be the exact same as right here. Alright, so let's do this graph. Let's think about, first, what is this going to equal at 0? Well, the tangent of 0 is going to be the sine of 0 divided by the cosine of 0. And to evaluate this, let's remember what it means to have the sine and cosine function. And if this is new to you, if you're not familiar with this before, there are previous videos that we've made going over what the sine and cosine functions mean geometrically to help you remember them. So, but without that out of the way, let's just look at this. So, the sine of 0 means what is the y position at 0 degrees? Well, clearly we've gone 0 up, so that's going to equal 0. And then the cosine of 0 is the x position at 0 degrees, which is 1. 0 divided by 1 is just 0. That means that the first point we're going to plot here is going to be x of 0 makes y go to 0. What about pi over 4? Well, at pi over 4, if we remember radians, pi over 4 is the same thing as 45 degrees. 90 degrees, which is pi over 2, over 2. So what is the sine of 45 degrees? The sine of 45 degrees asks what is the y position at 45 degrees, and the cosine of 45 degrees asks what is the x position at 45 degrees. Well, 45 degrees is special in that sine and cosine are the same. They are both the square root of 2 over 2. And the square root of 2 over 2 over the square root of 2 over 2, that just equals 1. So let's get some units here. This will be 1, 2, 3, 4, 5. This would continue on and on. So at pi over 4, we're going to graph this at 1. Now, one thing to remember here is that my scales are different. So 1 unit on the x-axis here is pi over 4, whereas 1 unit on the y-axis is just 1. And you remember that, but you're still going to get the general shape of this. And the tangent function is interesting because whereas the other trig functions that we've learned about so far, sine and cosine, are just kind of wavy, the tangent function has a unique shape compared to them. Okay, well, if we go on to pi over 2 now, when x equals pi over 2, the sine of pi over 2 is 1, so we think about going all the way 90 degrees. We have the y position is 1, and the x position is 0. 1 divided by 0, that's undefined. So we can't actually graph it at pi over 2. We could say at pi over 2, there is some kind of an asymptote. But we can't actually graph it there. What is it, though? Well, to do that, we could think about what is tangent just before pi over 2, or just after pi over 2. And if you think about it that way, you see that around this 90 degree point, around this pi over 2 point, you have the sine is almost always going to be around 1, right? But the cosine is what starts to change. The cosine here draws nearer and nearer to 0. So as you have these lines, I'll redraw the circle, as you have these lines going somewhat close to 90 degrees, and then closer to 90 degrees, and then closer to 90 degrees. As you approach 90 degrees from the left here, going up, cosine is going to become closer and closer to 0. And as you divide by smaller and smaller numbers, the answer gets bigger and bigger. So we can say that this is going to go off towards infinity up here. So now if we connect up our lines, it might look something like this. This is going to be an infinite asymptote. But then if we look from the other side, going as if we're continuing past this point and looking at it coming from this way, what are we going to get? Well, sine is going to be about 1 again, but now the cosine is going to be a small negative number. So it might be 1 over negative 0.1 or 1 over negative 0.001. And something really small dividing something else except that it's negative, that's going to come out to really small number. So negative infinity. Hopefully that train of thought makes sense. The sine is about 1. If you go from the right, cosine goes from 0.1 to 0.01 to 0.001, and as you divide by these things, you get closer and closer to infinity. If you come from the left, though, which is what you do to the right of the asymptote line, it is negative 0.1 or negative 0.01, and you get closer and closer to 0 from the other direction. So you have a very, very far down point there. All right, now let's think about 3 pi over 4. Well, if we think about what this is going to be, it's going to be here at 135 degrees. Well, the sine of this is going to be root 2 over 2. The cosine is going to be negative root 2 over 2. So if we added a negative sign here, then the answer just becomes negative 1. So we can graph here negative 1. So let's continue our markings down here. 4, 5, 1, negative 1, negative 2, negative 3, negative 4, negative 5. So we're going to just graph at 3 pi over 4, negative 1. And I'm going to be going slightly over what I've written, but it's okay. Now, if we were going to go all the way across 180 degrees, what are we going to get? Well, sine of 180 degrees, 0. Cosine of 180 degrees, negative 1. So we're going to get 0. Whoops, wrong color. And there's something interesting to note now. So because we're dividing by these two functions, we really are only going to get new information whenever the functions have different signs, right? Where either they're both, when dividing them gives you either a positive number, or when dividing them gives you a negative number. Because of the way the circle works, right here, if we went down here to 45 degrees past 180, we're going to have we're going to have positive 1 here for tangent, right? Because the sine is going to be negative square root of 2 over 2, and the cosine is also going to be negative square root of 2 over 2. This is going to be the same as right here, right? And just to drive what I'm trying to say home here, that's because if you take the sine of an angle plus 180 degrees, well, that's just going to get you to negative sine of the original angle, right? And if you were to take the cosine of an angle plus 180 degrees, that's just going to give you negative the cosine of that angle, right? Because you're just flipping yourself around, right? If you started here and then you went here instead, well, you're just flipping the x, flipping the y. So if you're dividing the sine of x over 180, x plus 180, and cosine of x plus 180, it's the same thing as dividing negative sine of x over negative cosine of x, and then the negatives just cancel out, and you get the sine of x over the cosine of x, right? So going up, when you're 180 degrees forward, it's the same. That's a long way of saying the period of the tangent function is pi, not 2 pi, because you're dividing. So if we connect this up here, connect it up better, maybe, we have this. And at this point, what we can do is we can just go ahead and copy this. This is just going to continue on. So now we're going to have this same upwards motion. So we're going to go up a little bit, and then here, 2 ticks forward, we're going to have another vertical asymptote, right? And at this vertical asymptote, we're going to go something like this. Go up again, and then we're going to come down from infinity, go to 2 pi, right? And you see it looks at 2 pi just like we had at 0. If you were to go to the left from 0, you would continue this downwards, and you'd have some kind of, I should draw this better though, you have some kind of asymptote there as well. Alright, there we go. And this shape would continue. Every pi units, you go up from negative infinity, go to 0, and then you go up back to infinity, and you do it over and over again. Hopefully this exercise of plugging in numbers helps you see why that's true algebraically. And just quickly, before the video ends, I want to give you a very nice geometric way of looking at this. And so first of all, when you first heard of tangent, I'd bet you thought it might have something to do with tangent lines, right? Because they share the same word, tangent, tangent line. And it's not clear at first what this tangent line could be, but I'll show it to you. So if you have the unit circle here, I'll draw it. If you have the unit circle, what the tangent function is asking, just like the sine and cosine function, were both functions that answered a question. The sine and cosine functions answered questions about the x and y coordinates given going up an angle. The tangent function asks something slightly different. It says, if I go up a certain angle x, and you draw the line tangent to the circle from where I am, consider, I'm going to redraw this line, because you just consider going straight from the point down to the x-axis. What is the length of this line? The length of that line is tangent of x. So if your angle is 0, your line would have no length, because you start at the x-axis, and you have nowhere to go. So you're already at the x-axis. That's why the tangent of 0 equals 0, as you see on the graph. At 45 degrees, you have a length of 1 to go, because this is an isosceles triangle. On the unit circle, this is length 1, so then it's isosceles, sides have to be the same, so tangent of 45 degrees has to be 1. Tangent of pi over 4 is 1, that's why this is 1. As you go closer and closer to the 90-degree mark, your lines get shallower and shallower, so the distance you have to go before you get to the x-axis grows unbounded until finally, at 90 degrees, you never make it to the x-axis. That's why you go out to infinity. Hope it makes sense. As you're moving along this curve, I'm just drawing it zoomed in, it takes, your lines go from not that shallow to getting shallower and shallower until at the very tip, they're parallel to the x-axis, so they never hit. That's the geometric understanding of tangent. But this video is running a bit long, so I'm going to end it there. Hope it helped.